Welcome to Star Chat, the podcast, where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. Today, we're going to talk about a fascinating discovery that's shedding new light on the life cycle of stars. Imagine being able to witness the final moments of a star's life, just before it explodes in a spectacular supernova. That's exactly what astronomers have been able to do, thanks to the powerful James Webb Space Telescope. A team of researchers has used the JWST to directly identify a supernova progenitor star, a red supergiant that's on the verge of exploding. This particular star, known as SN 2025 Petite, is located in the galaxy NGC 1637, about 16 million light-years away from us. What's remarkable about this discovery is that the star is surrounded by a thick cloak of dust, which has been hiding it from view. The JWST's infrared capabilities allowed scientists to peer through the dust and observe the star in unprecedented detail. The data revealed that SN 2025T is a massive red supergiant, one of the largest stars in the universe. It's also incredibly dusty, with a wind rich in carbon that's been dredged up from deep within the star. This discovery has significant implications for our understanding of how stars live and die. For decades, astronomers have been trying to understand why they've had trouble finding red supergiant progenitors. Now it seems that these stars may be hidden behind thick veils of dust, making them difficult to detect. The JWST's observations suggest that the most massive aging stars may be the dustiest, and this could explain why they're so hard to find. This breakthrough is just the beginning of a new era in supernova research. With the JWST and future telescopes like the Nancy Grace Roman Space Telescope, scientists will be able to study these explosive events in greater detail than ever before. We can expect many more exciting discoveries in the years to come. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're glad you're still with us as we explore the wonders of the universe. In our previous segment, we discussed some exciting developments in space technology. Now, let's dive into a fascinating story about supernovas and the James Webb Space Telescope. You might recall that supernovas are incredibly powerful explosions that occur when a star runs out of fuel and collapses in on itself. But what triggers these massive events? Scientists have been trying to answer this question for decades, and now, thanks to the James Webb Space Telescope, they've made a groundbreaking discovery. The telescope has identified the progenitor star of a recently discovered supernova explosion, known as SN 2025 Ph. This star was a red supergiant, about 15 times more massive than our Sun, and it was surrounded by a thick blanket of dust that hid much of its brightness. But with the James Webb Space Telescope's powerful infrared vision, astronomers were able to see through the dust and learn more about the star's properties. What they found was remarkable. The star was roughly 100,000 times brighter than our Sun, but it appeared more than 100 times less luminous due to the dust surrounding it. This discovery could help solve a long-standing mystery: why many massive red supergiants that should explode as supernovas are not seen doing so. It's possible that they're hidden behind heavy dust clouds that block their light from previous telescopes. The James Webb Space Telescope's findings also revealed some surprising details about the star's chemistry. The dust surrounding the star was mostly made up of graphite, a carbon-based chemical, rather than oxygen-rich minerals, which are more commonly found in red supergiants. This could indicate that some red supergiants undergo unexpected changes late in life, perhaps shedding material or mixing elements in ways that alter the grains they produce. This discovery is a significant step forward in our understanding of supernovas and the stars that produce them. And with the James Webb Space Telescope and future telescopes, like NASA's Nancy Grace Roman Space Telescope, scientists will be able to study more dusty environments around dying stars and catch them in their final death throes. That's all for this segment of Star Chat. The study of supernovas and the James Webb Space Telescope is an exciting area of research that continues to reveal new secrets about the universe. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, where we explore the wonders of the universe and our place within it. As we continue our journey through the cosmos, let's take a moment to appreciate the vast expanse of space and time that surrounds us. From the billions of galaxies that stretch out before us like diamonds on black velvet, to the intricate dance of celestial bodies that weave together in a grand cosmic ballet, every moment is an opportunity to marvel at the beauty and mystery of creation. Today, we're going to talk about one of the most fascinating phenomena in the universe: binary black holes. These cosmic monsters are drawn to each other by their enormous gravity, initiating a powerful orbital dance that spirals closer together over time, until one subsumes the other and they merge. This process is one of the most energetic events in the universe, releasing an enormous amount of energy in the form of gravitational waves. But despite their elusive nature, scientists have finally captured the first image of two black holes circling each other, located at the center of a quasar called OJ287, about 5 billion light-years away from Earth. This quasar is an extremely bright galactic core that forms when the black hole at the center of the galaxy devours surrounding gas and dust. Using a system of radio telescopes, the scientists behind this study identified the pair of black holes through the jets of particles they emit. The bigger black hole is around 18 billion times more massive than the Sun, emitting a giant bright jet of particles. The smaller black hole, which is about 150 million times the mass of the Sun, is twisted, appearing as a wagging tail due to its faster spin and twisting motion. This discovery offers a rare insight into the interactions of the universe's most mysterious beasts. By studying these binary black holes, scientists can gain a better understanding of how they form, evolve, and interact with their surroundings. This knowledge can also help us better understand the history and evolution of the cosmos itself. As we gaze out at the stars, we're reminded of our own place within the grand tapestry of space and time. We're part of a universe that's full of mysteries waiting to be unraveled, and every discovery we make brings us closer to understanding the intricate web of relationships that binds everything together. So, let's take a moment to appreciate the beauty and complexity of the cosmos. Let's marvel at the dance of binary black holes and the enormous energy they release as they merge. And let's remember that we're all part of this grand cosmic journey, connected by our curiosity, our sense of wonder, and our desire to explore and understand the universe. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars, for in the words of Carl Sagan, somewhere, something incredible is waiting to be known.